Welcome everyone to this great occasion. We do have a number of apologies tonight, particularly from David Officer and Will Price, and a number of others which I won't go through, but we'll pass on to Barbara. There's a number of people that are consumed in other activities off campus at the moment. So this is always a very special night for us here at IPRI at the University of Wollongong. So a very warm welcome to everyone who's been able to make it along tonight. All of you are distinguished guests, but a particular welcome to Barbara and the family, of course. So we're here to celebrate a legend, remember a legend, Leon Kane-Maguire. And Leon really did leave an amazing legacy. I know this is the first time I've actually tried to MC this event. Other people have usually done it, so I haven't got to throw my two bobs worth in. And others have done a great job in reminding us what Leon had done for us. But you know, he did help us to put together a lot of things which we still celebrate today. So Leon was, some people here will remember this, was actually quite instrumental in helping putting together research institutes at the University of Wollongong back when we didn't have research institutes. And I have to say that the first institute we put together wasn't particularly famous, let's say, but the name lives on. The Institute for Molecular Recognition, and Bill might remember that institute. And the reason it lives on was the only thing good about that institute was it had a bloody brilliant brochure. And we spent about 50% of the budget on the brochure and about 90% of our energy on putting this brochure together. Not that it would come of it, but that brochure must be still around in the university archives because I'm sure it gets rolled out as an example to people. You know, this is how you should put a brochure together. It might not work, but it had a great brochure. But now we learned from that. Of course, we went on and established IPRI after that, with Leon very much at the forefront of that. And that has gone on to be fairly successful. We don't have a brochure, but we do have a few other things. We moved on in time. We have a website and all that sort of modern stuff, Twitter handle, Twitter account, not everything else. We don't really be lost. So we still hang on with the brochure going around. But you know, it was all this. That was the start of something great, and Leon really did contribute to it and continued to contribute, of course, as we went through our quest for Centre of Excellence funding. Leon wrote most of those proposals that we put together for Centre of Excellence funding. And yet again, the actual first attempt to do that, of course, wasn't successful. It was a sort of common thread of these stories. It wasn't successful. The ARC knocked us back. But they did visit us, decided to give us a little bit of money to keep the group together. And so it wasn't quite a centre of excellence. Leon and I call it a centre of mediocrity. And we moved on from the centre of mediocrity and finally got a centre of excellence or two. And that hasn't done too badly at all. And this building as well is a testament to what Leon was involved in. He was very much driving the proposals around getting the capital funding for these buildings together here at the Innovation Campus. So we all enjoy these amazing facilities because of his amazing efforts. So before we get formally started tonight and I introduce the speaker, let me acknowledge the traditional custodians of the lands on which the University of Wollongong is situated, with our respects to Aboriginal elders past and present, who are the knowledge holders and teachers. We acknowledge their continued spiritual and cultural connection to country as we share knowledge, teaching, learning and research within the university. We also pay respect to the knowledge embedded forever within the Aboriginal custodianship of the country. So again, welcome. As I say, we're here to celebrate the legend, remember the legacy and really pay respect to that legacy that Leon has left for us. And our speaker tonight is being beamed in from just around the corner. Where's his daughter? He was there a minute. Oh, there he is. Dr. Robert Forster, who's sitting in the Great English pub in Dublin. He's got one of those false backgrounds on. All of the Guinness stashed onto the tables. You can't see him. I think Leon and I were thrown out of the Great English pub in Dublin one night for singing. Can you believe that? Thrown out of the pub in Ireland for singing. My God, look, he's to sing with me. Yeah, that's true, Robert. You get thrown out of the grave diggers for singing. He wouldn't have. So it's a great privilege to have Robert with us tonight. Robert holds a personal chair in physical chemistry at Dublin City University, where, of course, Leon built many collaborations with our colleagues in Dublin and visited there numerous times in order to develop those projects and make sure those collaborations were successful. Robert was elected to the Royal Irish Academy in 2020. He's led the development of a number of art equipment centres of excellence here in Australia, in Ireland, and established those over many years, and they've all been successful. More than 250 manuscripts, well recognised around the world as an outstanding researcher. And because of that, he's also a recipient of the DCU President's Research Award. So Robert has the global reputation for research excellence. His innovative approach has resulted in high-impact science and high-impact technological advances. He has an approach to collaboration, I think, that's akin to Leon's approach to collaboration, which was to embrace it, have fun when getting the job done, and then have some more fun after that as well, just in case you didn't have enough fun while you were getting the job done. So, Robert, thank you for joining us tonight. And I'm sure that we're all looking forward to your address. Hopefully I've said everything I'm supposed to have said, but if I haven't, it doesn't matter because I get to come back up again later. I'm going to hand over to Robert Forster. Welcome.
Good evening, everyone. It's a wonderful pleasure and a distinct privilege to be with you this evening. I'm sorry that I couldn't be there in person. And just to echo Gordon's words about a warm welcome to Mrs. Kane-McGuire, and we remember sons, daughters, and of course, Leon's mirror twin, Noel. So it really is a great pleasure to tell you a little bit about our collaborative work with IPRI and the ARC Centre in Australia. And really much of this work has been inspired by the wonderful foundation that Leon has laid for us. So Leon, for me, was a person who really created a cauldron of collaboration, somebody who brought individuals together, showed them that by working closely together, they could achieve much more than on their own. He really encourages all to think big, to believe big, to act big, and then the results would be big. And he certainly achieved that. You can see here, Leon never cast a shadow. He really shone a light on new science and really tried to bring out the very best in people and was truly a larger than life character. So despite this wonderfully big vision, Leon tackled some global challenges. And there has never been a better time to be involved in electromaterials and electrochemistry. We live in the generation of electrochemistry. Who of us today has not turned on a mobile phone, powered up our laptop, and all of that energy comes from batteries, electrochemical reactions, electron transfer reactions that generate the portable power that drives our lives today. When we think about climate change, the excess of carbon dioxide in the atmosphere, electrochemistry is going to solve this problem. Because when you think about countries like Australia that has abundant solar energy, or Ireland that has abundant wind energy, then we can begin to think about creating whole new chemical industries in these countries by taking carbon dioxide from the atmosphere and reducing it into useful fuels, such as carbon monoxide, or useful chemicals like ethylene that could be used to make plastics. When we think about the environment, we face some significant challenges globally. We think about the quality of water. Can we use electrochemistry to generate radicals that will destroy and break down these organic pollutants? In terms of health, can we develop sensors that will measure the concentration of disease biomarkers well before symptoms appear? Can we even go a step further, as we're doing with the IPRI and Gordon's group, to actually make a medical intervention that will improve the quality of life of patients? So these big challenges, inspired by Leon's vision, are what the IPRI and DCU are working on together. Despite Leon's big ideas and his big vision of the world and the future, he was very interested in the nanoscale. So here we're talking about length scales of about a billionth the size of a meter. And very often I think that we tend to forget just how challenging working at the nanoscale and producing nanoscale materials actually is. So if we were to think about Leon starting maybe in Brisbane and taking a wander around the entire coast of Australia, that would be round about 25,000 kilometers. And if we ask someone to pick up an individual shell, a seashell, maybe 2.5 centimeters in length along the seashore, somewhere along this 25,000 kilometer journey, that would be like trying to find a nanometer on a meter stick. But this is what Leon achieved. More than 20 years ago now, Leon and collaborators, Simon Mouton, Peter Innes, who I see in the audience today, were working on these nanoparticles of electronically conducting polymers. Again, these individual black dots are individual particles that are electronically conducting, and for those of you who are lucky to have some, about 10,000 times smaller than the thickness of a human hair. So not only have IPRI developed some fantastic materials, they have also integrated them into advanced manufacturing or processing techniques. So these smart materials have wonderful properties, but that's not enough. And this is one of the messages that Leon taught us, is that you have to integrate these materials into manufacturing technologies such as 3D printing or even 4D printing, design them in a useful way, ideally model them before you make them so they function correctly when you do make them, and then apply them in interesting areas such as robotics or bionics or chemical sensors. And we see that now with Gordon and Stephen working on the Tricep company that is actually selling these instruments that can use these advanced materials to make useful substructures. So we have wonderful materials. What about other properties? What else can we do in electrochemistry? Well, one of the things we can do is image those structures at very high resolution. So for example, Gordon and Maria Forsyth have developed scanning electrochemical microscopy to actually image on the tens and hundreds of nanometer length scale. So we have wonderful materials. We can image their structure and control their structure with fantastic spatial resolution. And now our own group have developed some nanoscale electrodes. The tip of this particular electrode has a diameter of about 10 nanometers. You could sit maybe 100 molecules on that surface. And now the key thing is that the electrodes will respond very quickly to changes in potential. Rather than the sort of 100 milliseconds that it takes most of us to blink our eyes, we can go 100,000 times more quickly in electrochemical measurements, and we can measure things down on the nanosecond timescale. So it's a wonderful time to be an electrochemist. Advanced materials coming out of IPRI, advanced techniques for their deposition and for their characterization. But electrochemistry is not without its problems. When we think about light, we can shine light into a sample and we can drive a chemical reaction anywhere we want within that solution. Electrochemistry is a little bit different. We have an electrode, typically a solid surface, and we have to transport reactants to that surface where they can, for example, undergo an electron transfer reaction, in this case, a reduction reaction, the addition of electrons. And the problem with this is that the transport of these reactants is slow. It's about the same speed as one of Australia's largest snails, the giant panda snail, can actually move. The diffusion rates of molecules in solution is very slow. Other problems, when you think about the wonderful work of Professor Graham Clark in terms of cochlear implants and the bionic ear, if you will, we want to make numerous connections to that cochlea at different discrete sites. Current state of the art, about 16 electrodes. It's not really enough to give you very high fidelity hearing. When you think about deep brain stimulation for control of tremor in Parkinson's patients, it works wonderfully well, but again, a limited number of connections. And the most striking feature of this image is all of the wires. And when Gordon sees all of these wires, he doesn't have a smile on his face. he begins to think about how we could solve this problem. Could we, for example, think about, like many of us do, wirelessly charge our phone? You take your Samsung, your iPhone, you place it on a charger, and there's no wired connection to this mobile phone. It charges wirelessly. And so about 5 or 6 years ago, Gordon and myself got together over coffee in Bath, and we began to discuss how this issue might be solved. And there is a solution. And the solution is to take a pair of external electrodes, use those to generate an electric field, and then you can place an electrode in that electric field, and you can induce voltages within that electrode wirelessly. So this electrode is not physically connected to any power supply, but we can drive oxidation reactions at one end and reduction reactions at the other, all wirelessly. The big effect of this was to dramatically cheer up our good colleague, collaborator, and friend, Gordon Wallace. And so our first area of collaboration, well, to be truthful, it wasn't really collaboration. We, as you'll see in a moment, we inherited all of the wonderful work that Jun Chen and Shunyan and Jilan and Gordon did in IPRI. But the idea is to try and use electrochemistry to electrostimulate cells, maybe to make them grow in the case of a spinal cord injury, or to block signals associated with chronic pain. Remember, while pharmaceuticals have been extremely successful, the cost of producing a new drug is about $10 billion, and many of them are not successful. And so the idea is that we would develop a electronically conducting coating. And this work really goes back to Leon's conducting polymer work with the nanoparticles, to make a conducting polymer surface that you could grow cells on, for example, nerve cells. And then that you could make the electrical connection, drive the electric field, and now electrically stimulate these nerve cells to, for example, differentiate, produce neurites, and start to form the interconnections that could, for example, ultimately repair nerve damage associated with diabetes or with traumatic injury in a spinal cord. And so what Jun and Shunyan and Jilan were able to do was to produce biocompatible surfaces based on this conducting polymer, polypyrrole, doped with dodecyl sulfate and a protein collagen. And these cells will live quite happily on the surface. As you can see here, the cells are round. They don't physically look like nerve cells. They don't have the neurite growth that we would associate with typical nerve cells in vitro. But then the magic happens. Turn on the electric field, electrically stimulate these cells, and now Shunyan was able to get the cells to grow and to produce neurites that would interconnect the individual cells. And now you have a communicating array of these nerve cells that have a biomimetic function, that really replicate the properties of nerve cells within the living body. As I said earlier, we inherited this wonderful surface. Shunyan came over to DCU, transferred her microfluidic electrochemical cell, her platform, her films that cells would grow on, and we then looked at another electrically active cell line, cardiomyocytes. We were able to grow those cells on the surface, differentiate the cells into cardiomyocytes, form assemblies of those cells, and actually to get these cells to beat in rhythm as they do in the beating heart of a living animal. The other area that I want to talk about is in terms of disease like epilepsy. And Leon really saw that vision of developing new materials, certainly publishing high impact papers, but also translating them for patient benefit. So about 4 years ago, we set up the center, the Future Neuro Center for Specializing Neurological Disease. Again, very much like the ARC Electromaterials Center of Excellence, trying to bring different disciplines, medics, clinicians, material scientists together. And one of the areas that we've worked on there is the detection of microRNA biomarkers within epilepsy. What we do is we start with a bipolar electrode, one of these wirelessly addressable electrodes. We immobilize, capture strands on its surface. If the appropriate target is present, for example, this miR-134, it will bind to the surface. We can then bind a redox active label, and in the presence then of a co-reactant, it generates light. So the idea here is the amount of light that we generate wirelessly depends on the concentration of the disease biomarker in the sample, in the blood or the plasma sample of the patient. And so what we can do is we can measure the intensity of that light as a function of the microRNA concentration. And that all works very well. As Gordon once said, never let reality stand in the way of a good story, but problems occur. So here, for example, is a nice photograph. I'm reliably informed that they're Australian whites, but this is the life of an analytical scientist. Here, we're trying to find the one black sheep in this ocean of Australian whites. The image has about 250 white sheep and one black sheep, and you can see already that it's quite hard to pick out the black sheep. A little bit like Leon walking around the coastline of Australia, that's not the scale of the problem. Typically what we're trying to do is trying to find one molecule in the presence maybe of 10 billion other molecules, and we're trying to do that selectively. And this is where the sensitivity that can be achieved through collaboration comes into fore. Rather than taking a planar or a flat electrode, Gordon and Stephen's idea was, let's make a three-dimensional electrode. Let's make an electrode, for example, that has these pins that project out into the sample, increase the surface area. And then in Dublin, we were able to model using ComSol modeling the electric field distribution. We were then able to image the actual electric field of these electrodes and show that these platforms can dramatically enhance the sensitivity of detection. So we could find that one black sheep in the presence of 10 billion other sheep. Again, speaking to Leon's legacy of moving that into practical application, we were then able to take that device and measure the concentration of this microRNA initially in epileptic mice. And you can see here that initially the concentration is low, and then it begins to rise. And sometime after the onset of this rise, the mouse undergoes a seizure. And this is really one of the holy grails in epilepsy, is to try and predict when a seizure would happen, so that before you go on a journey in your car, you know what the likelihood of you suffering a seizure would actually be. A second mouse, again, initially the concentration is low, the concentration rises, and again, at a certain period after the onset of this rise, an epileptic seizure occurs. A third mouse, same process. One of my points here is that we need point of care or point of need diagnostics, because each of these mice is an individual. Their individual responses are different. Their baseline concentrations are different. The time between the rise and the triggering of the seizure are all individual. And what we need is that tight integration of wonderful new materials with devices that can be used ideally in the patient's home. We've initially started this now. We've just got one patient, one human patient, but the results are encouraging. Again, we can talk about the ethics of this. What you're trying to do is you're watching the patient, you're recording their concentration, and you're hoping that they will have an epileptic seizure so that you can strike this correlation between the miR-134 concentration and their seizure status. Finally, then, very quickly tell you about our third project, which is on wastewater treatment. We're all aware of the water shortages, at least on occasion in Australia. I know there've been quite a lot of flooding lately, but our objective is to use this wireless technology to generate these very powerful radicals electrochemically, wirelessly, and use those to decompose organics within the wastewater, convert them into carbon dioxide, ammonia, and water, and produce purified water where it can be used locally. And so what we've done, we've used 3D CAD design to create these reactors, 3D printed them. And then what we do is we put in boron doped diamond particles into the reactor, control their voltage wirelessly. And again, coming back to the giant panda snail, The idea here is that by using a distribution of particles, the particles fill the volume of water. Now molecules, pollutants in the water do not need to move as far, and therefore you can do the reaction much more quickly. And that's shown here. By using some of these small particles, the kinds of particles Leon pioneered, we can destroy all of the bacteria within a wastewater sample that comes from the municipal wastewater treatment plant here in Dublin, and we can destroy all of those bacteria within round about an hour. And so I'll leave you with some conclusions. I could leave you with some grand statements about global collaborations and nanomaterials and wireless electrochemistry, but I thought, given that this is the LKM session, that I would do it a little bit differently. I think that one of the key things Leon has left us with is a recognition that humor and incredible science can be done together. And very often that humor, that sense of openness and transfer of ideas within a lab can lead to even more powerful science. He also taught us to worry about the small things, to see the incredible power that can be accomplished by using nanoparticles, for example, and also to be careful about understanding the details and the mechanisms, for example, of how things are working. Leon spent a significant amount of time in Wales and I believe had a deep affection for the country. And here's a Welsh saying, "A fo ben bid bont." And what this says in Australian is, to be a leader, first build a bridge. And for me, that's what Leon did. He built bridges internationally, as Gordon has said, with our own Dublin City University, what is about 16,000 miles away from Wollongong. That was what he could do. He was a larger than life character, inspirational in his science, inspirational in the way that he dealt with people and built them up. And finally, to say thank you to Mrs. Kane-Maguire, to the Kane-Maguire family, and to Gordon and Sam for organizing today's session. Thank you so much.
Thank you, Robert. So you can hear where that false background now. So we can see where you really are, and you can sit underneath the table. You've done your work for us. Thank you. That was a tremendous lecture. We won't go into questions or anything tonight, but if anyone would like to contact Robert, just you contact Sam after the talk today. Sam can get you in contact with Professor Robert Forster over at Dublin City University. So thanks, Robert. That really did capture all of the excitement of great science that can be taken through into great applications without compromising one or the other. And I think that's what we've all learned along this journey. And as you highlighted, the need for collaborations in order to travel that whole pipeline from ideas to industry. I think you'll also agree that Robert presented with the sort of passion we would expect at a Leon Kane-Maguire lecture. There's one thing Leon was, one of his other attributes was to be passionate about whatever you were going to do, and Robert certainly displayed that passion tonight. And also, Robert mentioned about Leon's humour. I was going to say something at the start of the introduction, but with all of those characteristics we talked about at the start, building up collaborations, building up great scientific programs, getting new buildings, it was all done with great humour. And all of the disappointments were faced with great humour as well, which is another thing that we learned from Leon. And that humour really resulted in some great camaraderie, I think, not just for the good times when we were celebrating wins and celebrating great achievements, but for those times where, as we encountered in research most of the time, where there was times of disappointment, and that camaraderie was really important, and that humour was really important. And I've heard it said that Leon's humour was somewhat wicked humour. No way. I mean, Leon's humour transcended wicked. I think it was very wicked. It's much more lethal than wicked. It's interesting, some of our great collaborators have ended up being great collaborators, coming from the United States, for example, for the first time, and meeting Leon for the first time. Really didn't quite get this. what is this going on? But they hung around in the collaborations through as they did with DCU and resulted in great things. So I'm going to hand over to Barbara now. That's the program. Yeah, and Barbara's going to say a few words, then we've got a video, and then we'll continue with the program. That's why I haven't messed up the program. Just wait a moment. Barbara Kane-McGuire Address.
Thank you, and thank you all very much for coming tonight to celebrate Leon's life and work. It's always so encouraging to see friends and colleagues here in the audience. And thank you very much, Gordon, for generously hosting this event every year. And to Sam, a very special thanks, because she's done the work and the organisations, and I have been such a help. Thank you. Thank you. I really enjoyed the lecture from Rob. Don't think I ever met him. No, I met him.
He said he's met you, but it's a forgettable sort of character.
I found his presentation. It's terrific, but I can't remember the name.
Yeah.
So I was there once, 4 weeks.
It might have been over here.
I'm very pleased to have my son John and my daughter Nicole here with me tonight. 2 of my 3 children. Today, coincidentally, would have been Leon's 80th birthday, so it was quite fortuitous that Leon chose this night to have it. So it's a special occasion. We're sad, of course, that we can't throw a big party for him, because we all know he loved a good party, and especially if he could wear a silly hat like you saw in the photo party. It's big on hats. I have spoken to his twin brother this morning on Zoom, which was lovely. Yeah, it was just really nice to chat with them. It was amazing how many times we actually forgot to send Noel a birthday card. We didn't actually forget. Noel, as a lot of you know, lives in South Carolina. And before the days of computers, of course, you have to write the card and send it in. It used to take about a week to 10 days. No, more than that, 10 days to a fortnight, I would say, for the card to get there. If you were going by Australia Post and then USA Post. So you had to allow that time and buy the card in advance and then get it in the mail with a 2-week span to get there, and we invariably forgot to do it early enough. So poor old Noel got a lot of late birthday cards, I think. But fortunately, he's a really nice guy and doesn't seem to have held it against us in later years. So I'd like you to enjoy this visual presentation, which Noel actually put together for Leon, with some help from all my children, my eldest son Andrew, John and Nikki, I think, all contributed, and I believe Vicky did too, with some photographs. You know, so I know some of you have seen it before, but I think it's worth a second viewing, and what better occasion than this day? So please enjoy it. Leon loved students. They were just such a huge part of his life, and all through his career, his teaching and mentoring roles, he just loved them. He loved seeing his students achieve and loved going to graduation and seeing all the happy smiles on the parents' faces. Didn't mind sitting up on the stage for hours on end. He was quite happy with that. I think it's always so appropriate to give this award because of his interest in students, and I always feel it's very apt to be handing this on to tonight, two students, two brilliant students. I'm very grateful that over the last few years, the School of Chemistry and Molecular Bioscience has been supporting me in this award, and that means a great deal to the students. Especially this year, Professor Adam Treveth has agreed to continue on the tradition. And he's not able to be with us here tonight, but Dr. Cara Von No is here with us, and she's going to come up and give you a little rundown on the awards and what the students have actually achieved and to deserve these awards. She is the coordinator of the master's course.
As the incoming Bachelor of Science Honours Coordinator, it's a great pleasure to be here tonight, and it's really exciting to co-present the Leon Kane-Maguire Student Prize along with Barbara. So thank you for allowing me the opportunity. In tribute to Leon's long-standing and seminal contributions to the field of conducting polymer chemistry, the prize tonight is awarded to the highest achieving School of Chemistry and Molecular Bioscience honours student who had the highest weighted average mark across chemistry and nanotechnology subjects over not just 1 year, but all 3 years of their degree. So for those who aren't familiar, the honours program is an end-on program conducted in the 4th year, and it's about introducing students to research at the forefront of modern nanotechnology and chemistry through a major year-long project supported by, in the case of these students tonight, some advanced coursework as well. Students take the knowledge they gain through their undergraduate study and apply it in a practical lab-based setting to extend their scientific inquiry skills, their communication and critical thinking skills, to contribute to solving a real-world research problem or question. At the end of their honours training, the students will have produced a piece of scholarly research in the form of a thesis. And if they want to go on to pursue a master's or a PhD, this is actually a prerequisite for them. The advanced experience for those acquired during the course substantially broadens the students' skill sets, allows the students to deep dive into scientific topics of keen interest to them, often challenging their thinking along the way, and then turning them into cutting-edge researchers with enhanced career and employment prospects. This year, for the first time, we will recognise the outstanding achievements of 2 awardees. But before Barbara announces them, I'd like to highlight their remarkable academic achievements. The first student achieved an average weighted mark of 93.2 across chemistry and bio-nanotechnology subjects and a Class 1 honours grade with an overall mark of 91%. And the second student achieved an average weighted mark of 93.6 across chemistry and bio-nanotechnology subjects and a Class 1 honours grade with an overall mark of 92%. It's absolutely outstanding, absolutely outstanding. So you can see that this sustained and exemplary performance has made it impossible for us to choose just one awardee. And so that's why we're awarding 2 prizes tonight. So with that, I'll hand back over to Barbara to do the honours and present this year's Leon Kane-Maguire student prizes. And I really look forward to following the careers of these 2 awardees. Thank you, Barbara.
just like your admiral, congratulations. I guess we do have the students here now, do we?
Yes.
Brother? I'd like to offer you my sincere congratulations, outstanding work, and wish you all the very best for the future. If you'd like to come forward, we've got your achievements awards here.
So the awards go to Bailey Hughes.
I think that concludes.
Thanks, Cara. Thanks, Barbara. And let me add my congratulations to our students, Rebecca and Bailey. I say this with some hesitancy. I was going to say, I hope you encounter a supervisor like Leon in your career, but I do. But let's just be prepared for the unknown. Yeah. But as Barbara says, Leon was an incredible mentor for students, staff, and all of us as we went through our research career. I think, as you've heard tonight, his passion, his resilience, his ability to build camaraderie really helped us to sail through some of the disappointments that I talked about at the start of the night, but also to celebrate the huge successes that we were able to enjoy together. So that was quite a journey. You've probably seen through that slideshow there that Leon was also a bit of a traveller. You probably didn't recognise me in some of those slideshow as well. There's a couple of stories about Leon travelling, but there's many, but there's hundreds of stands. But just two came to mind while I was sitting there. One was he was going to LA, and look, I don't know how true these are either because Leon told them to me. He's going to LA, and he was sitting next to a psychologist, and so of course you can imagine Leon sitting next to a psychologist for 14 hours. This poor bloke, many years, so he gets off the plane, he must have been shattered. He gets back on again, sitting next to him on the way back. And they're like, I said, oh no, you're a psychologist. He goes, no, come on. Little did he know the stories of Leon had about plumbing. And I can tell you a few about it, they're pretty spectacular. And there was another story about some young bloke. And he said to Leon, you know, they got the emergency exit, the extra leg room. I don't know what he needed extra leg room for. But he sit there at the emergency exit, this young guy, very young guy, turns out he's English, right? So they're flying to London and you know, starts talking about cricket. You can imagine how that went. Then about rugby and imagine how that went. So anyway, finally Leon does off and he wakes up and they've only been in the flight about 3 hours. Young fella's gone, so he has his meal and he said to the host, what happened to the young fella? He said, he requested to be moved. He said, I've got to say hello to him, where is he? They probably are true stories. You know. I'm not sure about the psychologist that became the plumber. I'm sure the other one is a true story. And just finally, the final travel story is that Leon and I went on, you see some of those trips to China, that was back in the days when there was no mobile phones. In fact, you had to book 2 days in advance to call home from China to talk to your family. And so Leon and I went on a lot of these early trips together. And also you couldn't get a flight to get out of the town you were in until you were in the town you were in. So it was like Russian roulette. You know, you turned up and you just hoped you would get out of there and get out there in time. So Leon and I thought about this later because it's always him and I that were being sent on these trips. We figured all these vice chancellors and deputy vice chancellors have been trying to get rid of us. And it never worked. We kept coming back, much to their disappointment. You can see the look on their face when we came off the plane. And it was, yeah, great fun and a great adventure. A great adventure all through life. I'm sure many of us have had that adventure with Leon. He's taught us all something. He's probably taught us all something different. But I think the key ones we've heard about tonight are that passions, resilience, and camaraderie. Thank you all for coming along tonight. Thank you for the people who had to come over a little bit later because of graduation. Welcome to our Vice Chancellor who's here with us now and everyone else who managed to get along tonight. I hope you have time to just partake of a drink, congratulate the students say hello to Barbara and the family, and say hello to each other, since we had the real luxury of being together. It's been a great night. Thank you for joining us, and we will always remember the legend. Thank you.